At this point, we've learned one of the most important skills of a web developer. We've learned how to provide users with forms, and we've learned how to take the information that the user fills out in those forms and do things with it on our server, like save it to our database. Now, in case you don't fully realize the value of being able to create forms for users and have them interact with them, think about sites like google.com, right? We use a search field, which is a form field, to submit information to the Google server so that we can see search results. Think about facebook.com. You create a profile, which you use form fields to do, so that you can then view your profile and share it with the world. Again, think about linkedin.com, a similar thing. You fill out form fields about your career information so that you can get jobs. Or even sites like Instagram. The list goes on. You have to work with form fields quite a bit in the web. It's one of the most common ways we interact with the web today. And you've just learned how to create form fields for users so that they can submit information to your server. Now, you've also learned how to take this information that you collect from the public, the information that people can fill out in these form fields, and save it to a database. So now, again, think about the importance and value of this knowledge as well. Taking the Facebook example, it's because of databases that you're able to log in 2 days later or log in from a totally different computer and still see the same exact profile you created, or even profiles of other people. All that information gets saved to Facebook's databases on their servers. Imagine if there were no databases, right? You could fill out these forms to create user profiles or LinkedIn profiles, but then you could come back a day later or log in from a different computer and your information wouldn't be saved anywhere. Databases are like the hard drive of the web. We're able to store information permanently and access this information whenever we want. Now, to be a true web developer, you really should know how all of this works under the hood. So let's take a look at the underlying technology that makes all of this work. So we've talked about this concept of the client-server relationship. The web browser on your computer or your smartphone is considered the client, and the word server refers to the physical computer or machine that takes requests from your web browser, the client, and sends back a response that ultimately renders out the page you want to see in the web browser. Now, inside these servers, people have installed software called web servers. And so whenever you pull up a web page, it's really your browser, which is just another type of software that's communicating with the web server. However, it's not the web server that comes up with the actual content that ultimately paints the web page for you on your browser screen. That's the job of the web application, which is just another piece of software that we install on servers, and we write that software using programming languages like PHP or Python, or in our case, Ruby with the Rails framework. So the web server is more like a middleman. So think about a website like YouTube. The programmers of YouTube created web application code that figures out what logo to show, where to place it on the page, as well as the buttons and videos. And then it's just the web server's job to ship that back to the browser that made the request. Now, thankfully, web servers and web browsers communicate using the same set of rules called HTTP. Imagine if you had one person that spoke English and another person that spoke Spanish, and they were trying to communicate with each other. They probably wouldn't get very far. So that's why we need HTTP. It keeps the communication organized, and it ensures that web browsers and web servers understand each other. That way they don't go into a communication frenzy and end up not producing the web pages that you want to see. Now, a while ago, some computer scientists came up with this concept called REST, which stands for Representational State Transfer. But don't let that terminology scare you. All REST really suggests is that we should think of things on the web as resources. So, for example, when you create a user profile on Facebook or LinkedIn, you want to think of that user profile or that user account as a resource. And when your friend creates a profile on Facebook, that's yet another resource. Or for example, with Instagram, whenever you upload a new image to the Instagram servers, that's a resource. Each image would be considered a resource. And REST also suggests that we should be able to do four main things with these resources. We should be able to create them, read them, update them, and delete them. So again, going with the Facebook example, think about your user profile as a resource, right? You can create a user profile whenever you first sign up for Facebook. Okay, so that's the create part. You can read it, and all that means is that you can view it, right? So once you've filled out your profile, you can go ahead and view that profile. You can pull up a web page that shows your profile picture and your first name and last name and things like that. So that's called the read part. Okay, so you can view your profile. You can also update it, which basically means you can go back and edit things, right? So you can go and change where you went to school or update certain things about your profile. And then finally, you can delete it. You can go back and delete all that information if you want. And so there you go. You've got those four verbs, those four things you can do to a resource. And most of the modern web today follows this concept of REST, okay, where you can do these four things. So think about any site that you've used or any web application that you've interacted with. There's usually those four things that you can do when it comes down to the very basics of it. Now, luckily, HTTP is compatible with this concept of REST. So we've looked at the anatomy of an HTTP request and an HTTP response before. An HTTP request looks like this, and it's what gets sent out by the web browser. And then an HTTP response looks like this, which gets sent back to us from the web server. And inside that response, down at the body of it, you've got the actual HTML and the content that ultimately paints the page. And that content is provided by the web application code. Now, you can even see these requests and responses happen in action. So if you go over to any web page, like the YouTube homepage, for example, and then right-click and then hit Inspect Element, and then head over to this Network tab here, and if we just refresh the page, and then scroll up until we see the homepage itself, youtube.com, this resource here, and if I click on it, you can see right here, this is the HTTP request that our browser sent out. It sent it to the server's address here, which has this domain name, and it sent a particular method called get. Okay, and then if we look here at the response, you can see that the response from the server contains all of this HTML, and this is what ultimately paints the actual page that we're seeing right here above. Now, I want you to pay particular attention to the HTTP request right here where it says request method and it says get next to it. There are four main types of request methods that are used in HTTP requests. There's the get request, which we just looked at, and then there's also post, put, and delete. Now, the get request is the most common type of HTTP request. Whenever you go to any web page like youtube.com or cnn.com and you just simply want to pull up a web page, all you're doing is you're sending out an HTTP request that has a get method attached to it. And all that means is you're trying to get a web page from the corresponding server. Now, your browser will usually send out a post request, so an HTTP request that has post set as its request method whenever you're doing things like submitting forms to a server. So in the example of Facebook, right, when you're creating an actual user profile and filling out that form and hitting submit, you're actually sending a post request to their server. Likewise, when you want to update something, your HTTP request might look like a put request or sometimes a patch request. And then finally, if you want to delete something, you'll often find that the request method is delete. So now think about how similar this is to the REST concept that we were discussing earlier with create, read, update, and delete, right? So you can send out a GET request, and that's similar to the read part of REST. You can also send out a post HTTP request, and that's similar to the create part of REST. And then likewise, put or patch from HTTP, that's similar to the update part of REST, and then delete is equivalent to delete. So Rails was built with REST in mind, and all that means is that when you're writing application code for your Ruby on Rails web application, you want to be thinking about those four actions, those four verbs that your users can do with any resource on your web application. They should be able to get things. They should be able to post or create things. And likewise, they should be able to update or delete things on your web application. So we've discussed how a Rails application and all the files inside of it interact with each other. So the browser sends out an HTTP request. The web server that's sitting on the actual server hardware catches that request and then communicates first with the routes file in the Rails application. From there, the routes file talks to the controller, and the controller is kind of like the master. It talks to the model and the view to gather all of the resources and the HTML needed, and then sends that back to the web server software, which then packages everything up into an HTTP response. So since Ruby on Rails was designed with REST in mind, it's able to work with the 4 HTTP verbs that we discussed right out of the box. So if you recall, when we added that one line of code to the routes file where we said resources contacts, we were immediately provided then with a set of URL patterns or routes that our users can go to in our web application. They can navigate to a bunch of different pages, and if you notice, all of those pages, they all have a corresponding HTTP verb that goes with it. So when you go to a certain page, depending on what kind of HTTP request got sent, a particular controller action then gets run. So what this tells us is by default, Rails comes pre-packaged, ready to work with these 4 types of HTTP verbs. And by linking these pages together that the users can request with particular controller actions, we're able to organize our code in a nice, clean way. For example, if someone's browser sends a GET request to our website at /contacts, then our Rails application knows to run the index function inside of the contacts controller. And remember, when I say function, all I mean is a set of instructions for the Rails application to follow. So likewise, if someone sends a post request to /contacts, then we run a different set of instructions. So now you know kind of what goes on under the hood whenever your browser is making requests to see certain pages in a Rails application. Now, if it doesn't click for you right off the bat, don't worry, we're going to run into these concepts multiple times again going forward. And I urge that you come back to this video and watch it a few more times down the line, and I think things will start to click. But the main concept that I wanted to emphasize for you here is how most of the modern web follows this principle of REST, where you can create things, you can read or view things, and then you can update or delete things. And how HTTP and Ruby on Rails can enable you to write code so that your users can do those 4 things.